In this video, we are going to learn how to use work energy theorem and work done by gravitational force to solve problems. The question says two baseballs are thrown off the top of a building that is 7.25-meter high. Both are thrown with an initial speed of 28.4 meter per second. Ball 1 is thrown horizontally and ball 2 is thrown straight down. What is the difference in speed of the two balls when they touch ground? So let us sketch the situation. You have ball 1 and ball 2. So let me call this ball 2 or ball 1. So ball 1 is thrown horizontally. It will fall on the ground like this. Whereas ball 2 is thrown straight down. Ball 2 will come like this. I need to find what is the difference in the speed of the two balls when they touch the ground. Now, since the two balls are thrown with the same speed, their initial kinetic energy will be the same because they both have the same initial speed. So kinetic energy of ball 1, initial kinetic energy of ball 1 has to be equal to initial kinetic energy of ball 2. And since they both cover the same vertical distance, work done by gravitational force on both the ball has to be equal because they are thrown from the same height. They cover the same vertical distance reaching the ground. So work done by the force due to gravity on each ball will also be the same. So work done by gravity on ball 1 is equal to work done by gravity on ball 2. We know from work kinetic energy theorem that work done is equal to change in kinetic energy. Work is equal to change in kinetic energy of the object. So since work done by the force due to gravity is equal, the change in kinetic energy for both the ball will also be equal. We can write the change in kinetic energy as final kinetic energy minus initial kinetic energy equals final kinetic energy of ball 2 minus initial kinetic energy of ball 2. Now we have already established that the initial kinetic energies are equal since they are thrown with the same initial velocity. I can cancel the initial kinetic energy over here from both sides because they both are equal. We can cancel them. This gives me the final kinetic energy of the ball are also equals. So K final for the first ball is equal to K final for the second. Now, if the two balls are identical, that means if they both have the same masses and they both have the same kinetic energy, their velocities will also be equal. Because kinetic energy is given by the rule half mv squared. So if they both have the same mass and they both have the same kinetic energy, their velocities, the final velocities must also be equal. So I will get, if I cancel the common terms here, half m, if I cancel the common terms here, I get v1 squared equals v2 squared. And when we take square root on both sides, we get v1 equals v2. Now, since their velocities are equal, the velocity when they reach the ground is equal, the difference in velocity will come out to be 0. So when I do v1 minus v2, my answer comes out to be 0. Question wanted me to find the difference in speeds. So when I take the difference in speed, it comes out to be 0 because both ball arrives at the ground with the same speed as they have the same final kinetic energy. Now this is one way of solving this problem by using work kinetic energy theorem. You can solve the same problem using another method, which is by using equation of motion. So let's consider the second situation where I solve the same problem using equations of motion. We have ball 1 having initial horizontal velocity and it is falling down according to projectile motion. And we have ball 2 that was thrown vertically down, so it is under free fall motion. So let's derive the equation for velocity for both of them and then we can find the difference. So let's start with ball 2. Now let the vertical distance covered by both ball be given as h. Initial velocity of ball 2 we will write as v0, which is 28.4 meter per second. The distance that it covers, delta y or y minus y naught, will be negative h. Negative because it is falling down. And the acceleration with which ball 2 is falling is acceleration due to gravity, which is negative g, negative 9.81. So let's put this in an equation. If I want to find velocity and I have been given acceleration and displacement, I have to use the fifth equation of motion, which is v final squared. Let's use another color, which is v final squared equals v initial squared plus 2a y minus y naught. Now let's substitute. V final squared will be equal to V initial. I will write as V naught. We won't substitute anything right now. Just write it as V naught plus 2a is negative g and y minus y naught is negative h. So Vy squared will be equal to V0 squared plus 2gh. Or we can write this as Vy equals square root V0 square plus 2gh. This is velocity at the bottom for ball 2. Now let's find the same thing for ball 1. Ball 1 is projectile motion. So in projectile motion, we have two components of velocity, the x component of velocity and the y component of velocity. Since the ball was thrown here horizontally, initially my initial speed for ball 1 will be just its x component. The y component, the initial y component will be 0 because it was not launched with any y component of velocity. It was thrown horizontally. But as it is falling down, the y component of velocity will change. The x component will remain constant. It will not change. So x initial is v0, whereas x final will also be v0 because x component of velocity will not change for ball 1. In projectile motion, x component of velocity remains constant. Then we find the y component. Y component initially is 0. So I will write Vy initial is 0. Vy final, we have to use the same equation we used here to find Vy final. So Vy final squared equals Vy initial squared plus 2a y minus y naught. We substitute the same thing. Vy final squared equals V initial is 0 plus 2 minus g minus h, or Vy squared equals 2gh. Now I have the x component of velocity and I have the y component of velocity. to find the final total velocity, I have to use the Pythagorean theorem because we have two components here. So my final velocity V for ball 2, sorry, ball 1, let me erase that. My final velocity for ball 1 will be square root the x component squared plus y component squared. X component is just V0, so I write V0 squared plus what is Vy squared? Vy squared we found as 2gh. So this is V1. Now compare V1 and V2. V1 is square root V0 squared plus 2gh. V2 is square root V0 squared plus 2gh. Both values are same because V0 is 28.4 for both and the vertical distance h that they cover is also the same. So the values of velocity, the magnitude of velocity for both ball at the bottom is the same. And since the magnitude of velocity is the same, when I take the difference V2 minus V1, that gives me the answer as 0. So you can use any one method which you find easier to solve a question like this. You can solve it either using work kinetic energy theorem, or you can use equation of motion to arrive at the value for velocity and get your answer.